Hi, I'm Shashwat, and my team is working on a project that is smart laptop cooling system. So basically, we are trying to create a laptop stand that controls the speed of the fan according to the temperature of the CPU. The problem is that the laptop stands or the cooling pads which we have online available in the market, the user has to manually adjust the speed of the fan, which makes it sometimes tedious. When the user sees lagging or down performance of his system, he then realizes that it may be the system cooling issues. So then on he or she increases the fan speed. But to overcome this problem, we have used Arduino Uno circuit to adjust the speed of the fan. So my job was to construct the 3D model for the laptop stand. We went across, or we went through a lot many images across web, and we came out with this design. We have not preferred adjustable fan because it was not feasible in such time limit. So we went ahead with a fixed angle laptop stand. So let me tell you how the laptop stand would work. This is basically the side view of how the laptop stand would look. So let me rotate it a little bit. Yeah. So we'll be using four of these base stands with two holes as you can see. And these four base stands will actually be the support for the laptop. So let me quickly take you through the basic steps that I took to create this model. And so first we start with a basic sketch. This is the basic design. And then using the pad feature and adding a little fillets to smooth out the edges. Then we created two pockets. For that pocket, we need to create two sketches for the holes. Use the pocket feature through the whole of this body, and then we smooth out the edges that we cut just now. And yeah, we're done with the model. And the use of these two holes is to support two rods actually. Let me show you this model of the rods. Yes, you can see here it is. A simple cylindrical shape. The use of these rods will be detailed in the later part of the demonstration. So these rods will actually go through the slot and then hold the frame together. So this was the overall view or picture of the modeling part. In the next segment, you'll see the circuit demonstration on the Tinkercad circuit that will be shown by PRIYABRATA.
Hi, I am PRIYABRATA SAHOO of Group 4, and today I am going to explain our circuit, which is based upon a smart laptop cooling system. So here we use a temperature sensor. Our temperature sensor is LM35 model, and this sits beneath the laptop processor, which senses its temperature and accordingly outputs an analog signal to our A0 analog pin, and this reading is used to decide further actions. Here we use digital pins to power our LEDs through resistors so that the current does not exceed the rated current, and then we have also connected a PSO buzzer which will create sound the moment the temperature has crossed a certain threshold, and the green LED keeps glowing until we are in the safe range of temperature, and the moment it crosses the threshold, the red LED starts glowing. Here we are using the L293D motor driver to power our motor, which is basically our fan. So we take input from the sixth digital pin, which produces a PWM signal. This is the code for this. So using the PWM signal, we can manage our voltage between 12 volts to 0 volts, so that we can control the speed of fan accurately and efficiently, so as to provide proper cooling. This is our voltage supply to the L293D, and then let's look at the working of it. So now, as we can see, the temperature is above threshold level, so the motor speed is about 16,000 rpm. The piezo makes sound and the red LED glows as we are in a dangerous range of temperature. So the user is advised to turn off the system or take appropriate actions. And the moment the temperature goes down, the green LED starts glowing, and then the fan slows down as it is now about 12,000 rpm, which is 3/4 of that speed. So this way we can control the speed of the fan, as well as indicate the danger to our user.
Hello everyone, this is our DIY project and I'm PRANAV. I'm looking for its hardware assembly and all. So let's get started with it. So there are basically two parts of our for our project. One is the hardware modeling and another is the assembly part. So first I'll start with the 3D prints that we have done. We have here four prints of L size shape, which will be our main structure. So there are three thicker rods, like you can see in the video. These are the three thicker rods, and these are the three thinner rods here. Okay, so I'll just assemble it for it. Here it goes. Here we are. I'll connect it like this. So you can get from like you adjust the rods. So like you can see this what it looks like, and I just put it on the ground where it get assembled properly. Yeah, and here it goes. So here what it looks like final stand. So this is the final how the project looks like. So there is green LED here, there is a red LED here. If uh, if the temperature on this temperature sensor, which will go under this thing, under the laptop, goes above a certain limit, which is explained in our explanation video, the red LED will light up and this buzzer will ring. So I'll just explain the circuit in a smaller, in a very small, like limited manner. Here is our L293, LD293. This is our Arduino Uno. These are the circuits which are like explained in the FreeCAD video, because it is very difficult to explain here. And this is our power supply. And there is that like okay, yeah. This is what the motor is looking like under this. Okay, so this is our motor fan, which goes under the, which acts for the cooling of this laptop. And let's test it out. Let's heat up this temperature sensor a little bit. I'm not sure that it is audible or not. I'll just hang up again. I think it's not audible, but you can see the LED has been red, green LED has been shut down, and red LED has been glowed up. So it's showing, and the fan is also working. I'm not sure it is visible or not, but it is working for the cooling of this thing. So this is our DIY project in which this green LED has been shut down, and this red LED glows up whenever the temperatures goes up, and this uh, buzzer rings when the temperatures goes above a certain limit. This is very useful project, and my name is Pranav. The project report is done by ARJISH Choudhury. Thank you everyone. Like you can see here, the green LED has again blown up because the temperature sensor has has gone down. So it's how the circuit works.